My name is Sangbae. I'm from MIT. Nice to meet you, everyone, and thanks for inviting me. There's a lot of work on organizing such an amazing event. So I'll go ahead and start. Hopefully I can finish in 10 minutes. So title is Physical Intelligence and Cognitive Bias Toward AI. I've been talking about this exact topic last about 8 years and emphasizing how important physical side of it. So hopefully I can deliver that today. So cut a little short to be 10 minutes. I'll briefly introduce our work, which is mostly about effort to bring robot outside the factory. How can you make available outside the factory? That pretty much sums up my first 10 years of career at MIT. And then I will talk briefly about our cognitive biases, why we had a hard time understanding AI, why we constantly misunderstanding AI and then causing issues in investment and so on. And third topic will be the future challenges. Hopefully this is a topic we can continue to discuss. I love to talk about this. Anybody want to have a further discussion? This is more like throwing a topic for the conference. So let's go. So first topic. So my pretty much first 10 years of career at MIT is about how can we design a robot that can actually work outside a factory, which is very different from factory setting, where factory all the robots are grounded on the ground or sometimes in the rail, but those are very ground. So you don't need to worry about balance. And then almost every operation position is actually determined. So if you go to the factory, 99% of robots are actually blind. There's some vision system, but most robots are blind. And then pretty much rely on high precision position accuracy. But once you step out of the factory, this is a picture from DARPA challenge in 2015, and everything changed. First of all, you have to move around, you have to balance position accuracy. You don't even know what everything is, and you have to really think about interaction. It's all about how can we make sure a robot can be interactive. So I will briefly show you all the works that surrounded by perceptive actuation, which is basically our work at MIT. And this is a Cheetah 2. This is probably the first electric robot that can jump and land and run at efficiency of an animal. So we achieve efficiency animal from the beginning. And now, thanks to our research on actuation, we can make robot very, very interactive. So don't fall by this like dynamic action. We show dynamic action because there's a lot of uncertainty. But it's all about developing actuation scheme that can be interactive with the environment. And we bring this paradigm into manipulation now, and then we can achieve like very fast action and then fast adaptation to the environment. And same paradigm in the humanoid, of course. And then this is a more our recent work. And same paradigm. If you look at those actuations, if you take it apart, it's really exactly the same as our mini cheetah. And also going to the more dynamic action, and then true top spin and underspin, not just like blocking like other researchers. So if I sum up our impact on proprioceptive actuation, before we introduce our Cheetah robot, hydraulic machines are dominating at the time. And Boston Dynamics shows amazing this action at Big Dog 2008. And Chinese version came out, Italian version came out, and many companies, I think one of them is North Korea or Russia. And Atlas robot, everybody probably know, to show the biggest lead. And then there's other robots like following more like a conventional manufacturing technique, a high gear ratio or harmonic drive. Sometimes have a spring or sometimes clutch. But after we show our proprioceptive actuation, it's almost like an explosion of robotics happen. And nowadays, if you go robotics conference, and you can probably find easily 30 companies are making the similar robot like a mini cheetah or our humanoid. And you can see a lot of companies in China making pretty much the same robot, allow you to be able to build an interactive robot. Finally, Boston Dynamics gave up hydraulics because my student actually gave a talk there, and then he got employed, and he basically designed the actuation scheme for a new Atlas, which pretty much copy our perceptive actuation that allow us to make robot more interactive. That interaction is actually center of our current today's topic: how to make robot physically intelligent. Or surrounded by the physical intelligence, I'm going to talk about cognitive bias toward AI, why we are so misunderstanding about AI. And there's so many topics I can talk about. I have actually 2-hour lecture on this, but I will try to make it as short as possible. The first, we judge the performance of AI or robotics in human standard. We are evolved to be a social animal. We are hardwired to judge based on how humans behave. If you look at your pet and then, oh, it's smiling. No, they are not. But we actually judge based on how we interact, how we understand the humans. And then we apply the same rule subconsciously in the robot all the time. And that's actually the biggest reason why we misunderstand AI. When ChatGPT answer, oh, you must understand and answer that way. No, it's not. But because this is how we are wired, we make the mistake even nowadays, 2024. Number two, that intensified by the fact that we actually don't know how we move. It's all about physical intelligence. I'm not saying we don't understand how we write. I'm talking about we don't understand how I'm doing this. Nobody's surprised the fact that I brought this. I'm going to show you one more time. And then I will ask you to do this right now. Try to bring something out from your pocket. If you have a chance, it will take only 10 seconds. We're so good at it. And then I'm going to ask you, any of you remember what your second joint of your index finger was doing? I'm pretty sure you're using index finger. I guarantee you, I've been asking this to 10,000 people so far. Not a single person came to me. I command sine, cosine at joint angle of the index finger so I can do this. This is completely blind spot our cognitive space. Your frontal cortex have absolutely no idea what's going on to do this. I didn't even use my eyes. And sometimes somehow it happened. This is basically one of the biggest challenges in robotics right now in the factory. Grasping, picking. General picking is still unsolved problem. It actually covers the biggest part of the automation challenge at this point. Another challenge is our language is so abstract we don't realize it. ChatGPT actually taught us, wow, language is so abstract. And then sometimes it's almost hard to make a complete mistake. It's hard to be wrong when you're using language because it's so abstract. And when you see ChatGPT hallucinate, oh, ChatGPT can make a mistake. We are so good at take a human language and then into concretize the grounding real world. Like for example, cleaning your room. Think about writing cost function that satisfy cleaning your room. But if you ask your 10-year-old or 12-year-old, they know what that means. Wash your dishes. Think about the wash, what does that mean? We're communicating with our languages at such an abstract level. We don't understand how good we are and taking that abstract concept and then concretizing and then making it to action. And the number four, our brains, we don't realize how we are making decisions. We're making decisions that are actually very qualitative. And sometimes, a lot of times, it's binary. Is it good or not? Honey, should I buy this or not? Is it good enough or not? What cost function should I use to decide to buy this cabbage versus this tomato in the grocery store? Just think about it. And I don't have time for talk about all these three things, but I'll give you a few points. Every time I give a talk, everybody, wow, backflip. And then nobody even look at the complex algorithm going on to really maintain balance. The backflip took about 3 days of undergrad. 2 undergrad made it happen in 3 days. Balance MPC, it took us 2 years to do system ID and trying to establish the convergence rate down and so on. Our brains are not wired to really recognize what is hard for the computer. We only know what is hard for human. And this is not the new thing. The old professors and the legend in AI talked about this. And then many people know it as the Moravec's paradox. But even these legends use language intelligent tests for checkers and some human thing. And then it's difficult, impossible to a 1-year-old come to perception mobility. They already underestimate the difficulty of the perception mobility. And then this might be the most important slide here. Just think about it. All the amazing thing we think human can only do, oh, we're so great. We're different from ape. We can write, we can do the math, we can play game, oh my God. Just think about those. Those are already conquered by computers. No human can compete with the computer at this point. Go, chess, even writing maybe. And math. If you go to all these modern technology, algebraic process, you can compete with the computer. Whereas things we think like, oh, I just show you or bring something from your pocket, we don't think those are intelligent. And those are all subconscious. Just think about this. we've been using languages a few thousand years, at most 10,000 years. Whereas we evolved to move and use our hands for millions of years. And then think about how we are underestimating difficulties doing physical stuff versus virtual stuff. Because our frontal cortex live there and aware of what's going on there. And that's not the case when it comes to writing program for the robot. So let's talk about what should we do. I don't want to take, it's not even my expertise, but everybody knows what's going on in behavior cloning world, and then there's every month there's new company pops up and then promising some transform foundation model for a physical world. And all these companies are showing very similar demo based on teleoperation, human demonstration. And I want to ask you just one question, two questions. If you collect millions of people walking in the street for about 1 million hours, that's a lot of data. Maybe you can throw a billion there. Can we teach a humanoid to walk? That's the first question. And the second question is, what happens if I shove the robot? Just think about it. This is where imitation technology, imitation learning hit the hard challenges. And if anybody thought about the answer, please come to me. I can talk about this forever. And by the way, that's actually kind of similar to like a young generation student. They memorize all these recipes and then how to solve. This is the term exactly my student use. Memorize the solution path, and then get the 108 plus in every classes, and then actually don't understand any contents. It's very similar to our current AI statuses. I can spend more than an hour on this, but I just want you to highlight how different the virtual intelligence space, which is what we saw in all internet, compared to the physical intelligence side. Let alone how difficult to collect the proper data, but I want you to focus on these two things: the cost of failure, and more importantly, uncertainties. What is uncertainties when ChatGPT spit out, "I have a lunch"? And sometimes came out lunch, sometimes came out lunch. No, that's not the case, right? There's no uncertainty. AI spit out the pixels and the RGB numbers. In physical world, every millisecond is uncertainties. So you can maybe think about solving cognitive intelligence, high-level intelligence. It's hard to draw a clear line. Maybe LLM. Maybe spatial motion intelligence. How can you move your arms? How should I go under? Should I go over? Maybe visual language model, maybe supply. The problem is we don't have a layer that can handle the uncertainties and then think about the physical reasoning. I think this is the essence of physical intelligence, and we don't have a proper tools. And this is a video of me picking an apple. Of course, I have no idea, and see how much interaction is happening, and then your finger is reasoning about it. So one idea in my lab we're trying to do with the reflex layer. So these are all very simple algorithms that designed to tackle things quickly in the manipulation world. And then we have about 4 or 5 different reflex layers. And then this could be actually very good action token if you think about token-based, the transformers or other high-level algorithms. And you can actually achieve relatively quick interaction and without worrying too much about, I need to follow the optimal trajectory, otherwise I'm not going to be able to succeed. Another topic I want to throw in there, because we're running out of time, I just want you to think about how do we mix data-driven approach, all these RLs or transformer-based or the foundation model-based, combined with the reasoning-based approach, or model predictive control, or any other reasoning-based, because these are very complementary. And then we are actually working so hard on this, and then I can talk about in person what we're doing, and then what we've been doing, and why I think it's important. And that's the end of my talk, and thank you for your attention. That was too long.
All right, thank you very much, Sangbae. We can't have philosophical debates, but we can maybe take a couple questions while the next speaker sets up. So, any?
Hello, thank you. Thank you for your talk. Very interesting, very impressive. However, I have 2 questions very quickly. One is linked to how can you say that the failure of an abstract decision is low.
Oh, so maybe I didn't explain clearly because we're running out of time. I'm talking about execution uncertainties. Once you decide to do something, and then can you actually do it? In a language model, you can think about pixel generation versus actually you're following a trajectory or applying some forces. Just think about action difference between virtual world to the physical world. I'm not talking about cognitive mistake or judgment reasoning mistake. I'm talking about action uncertainties. Stefano, yeah.
Fantastic talk. We agree on all you said. How can we give more attention to these kind of things in our community?
So this is every time I give a talk to some non-engineer, well, actually, it's not that different from either you're engineer, either you're roboticist or not, even reporters. I think it's about this physical intelligence is sitting in your back of your brain. It's not in your frontal cortex. So it's a blind spot of your natural, your cognitive functions. So it's very hard. You have to really force to, I need to practice. I even talk about this topic 8 years. I need to spend energy to actively think about it. And I don't know. IMDb just talking, and then we had to bring it up, throw questions. The typical thing to do in academia. There's no other way to do it. Another downside of the issue is we are so embedded in our iPhones and our digital. There's no interaction there. There's no physical interaction. We're losing touch of actual physical interaction because of this new technology. So I don't know. We should bring up more hardware. We should bring up this topic more. Thank you for asking that question, but that's one of my challenges too.